So, hello everyone, I'm José Valim. This talk is about Elixir, which is a language that runs on the Erlang virtual machine. We have only 30 minutes, so I'll go as fast as I can for the talk and save some time at the end to show some code. So one of the points we're going to discuss today is why. Like, why another language, right? So the main goal for Elixir existence is the Erlang virtual machine. Okay, well, this looks really big. Erlang for all of you. And Erlang was a language created by Ericsson. Who already heard of Erlang or played with it? Whoa, a lot of people. Okay. So who heard about it? Already heard? I'm sorry if I make you tired. And who already programmed, did something in Erlang? Okay, way few. Okay, so Erlang was a language created by Ericsson, and it's very interesting because when they created the language, they had a very specific set of requirements and use case in mind, right? So what you can take, for example, is that Ericsson, they wanted to build telephone switches, right? And a telephone switch needs to receive a call from one point and connect to the other point, and you have those two people talking. So a person A wants to call to a person B on the other side, and the switch is in the middle. But what you actually want in practice is that a switch is able to handle hundreds of thousands, possibly millions of connections at the same time. So they built a switch with concurrency in mind. So here's one of the use cases. So it needs to be highly concurrent. Having a connection open with the switch should be like extremely cheap. And what they also had in mind is that you can imagine that a telecommunication system has a lot of switches, and maybe the point A is already connected to a switch. So you need to communicate between switches and get information. Hey, I would like to talk to the person B. Is this person B already connected? It's like, is it busy? So it also has a mechanism of different switches, so different Erlang nodes, they should be able to exchange information between them. And all of this is already built in the Erlang virtual machine. So they have all those scenarios where they say, okay, we need to build something that's very good for this. One of my favorite examples that I like to joke about is that usually we don't receive like phone calls from our operator saying, hey, we're going to be in maintenance mode from midnight until 2 a.m., so please don't use your cell phone at this time because... So this kind of stuff doesn't happen, right? So they also have something called hot code swapping, where you can change the code that's running in production without having to bring the whole system down. So those are like some use cases for Erlang. And then Erlang was mostly used for telecommunication until around 2005, 2006, when people actually started to realize that this scenario that we have here is actually very similar to this. Right? It's very similar for you having a server, and then you have a bunch of browsers, and those browsers, they are connecting to the server, and you want your server to be able to hold and open as many connections as it can. So people start to realize, oh, we can actually use this for web stuff. And most of the web stuff that we are doing until the latest years was pretty much like this. We had a browser, and then the browser sends a request to the server, and the server sends a response back. And Erlang is going to be great for this case, but what is starting to happen today is that we're starting to have all those new clients, like HTML5 clients with WebSockets, and Android, iPhone, Windows, whatever, and they start to have they have their own use cases, right? So in WebSockets, you actually open up a connection to the server, and then you can stream data from both sides. And then you have API streaming, where you connect to the API and stay there all the time, just receiving information. And server-sent events. And in those cases, Erlang is going to be even better compared to the stacks that we use today, because most of our stacks, they were really thought in this scenario request response, and they're not really ready for a scenario like this where we want to open a connection, we want to keep this connection open all the time. In most of our stacks, what happens is that when you open a connection to the server, it blocks all other connections, so it's not actually concurrent. So Erlang is going to be great for those cases, right? So this is one scenario. This is one scenario for us creating a new language and basically be able to use the Erlang virtual machine. The second point is multi-core. We have a saying which is the free lunch is over, which is basically saying that our CPUs are not getting any faster. What is starting to happen is that we're starting to have more and more cores. And depending on how you are, I can talk about Ruby, if you're not, Charles Noto is here, so this does not apply to him. So if you're using Ruby, you're fine. But depending on the stack you're using, if you have 4 cores, what you actually have to do is that you need to start 4 servers to use all cores in your machine, right? If you're using Node.js, for example, and you have 4 cores, you need to start 4 node instances. So what you're going to do in 2 years when you have those machines with 50 cores, and they are going to be, there's a prediction from Intel that they're going to cost around $2,000, and you want to deploy your code in this, what are you going to do? Are you going to start 50 Rails instances? Are you going to start 50 node instances? And it's getting more and just more CPU. So that's not what we want, right? We want to actually have one server that's going to be able to use all cores in our machine. And again, the Erlang stack is ready for this scenario. You can just go and use it today. And my favorite is that Elixir, yes, it is a new language, but it runs on a virtual machine that is already out there for quite some time. So I'm not creating everything from start. So we have a lot of people that already use Elixir. So Amazon, they use, not Elixir, but Erlang, the Erlang virtual machine. So we have Amazon that uses Erlang in their SimpleDB, Facebook using their chat. We have telecommunication companies like Ericsson, Motorola, T-Mobile. They are all using Erlang. Heroku as well. Ryak is the biggest open source project running on Erlang. So that was the first part. So why we are creating a language, and what I did these first 5 minutes was basically trying to convince you that the Erlang virtual machine is a great technology, and that's the main reason for having a new language. So that said, what is our goals, right? So why I'm not using Erlang? What Elixir is trying to achieve, that it needs to be a new language running on this virtual machine. So I'll talk about Elixir goals, and I'll do comparisons direct to Erlang. In this case, Elixir, just to give you an idea, is also a dynamic language like Ruby and Python. It's a functional language. You don't have object orientation, and we'll see some examples soon. So the first goal that I want to achieve with Elixir is productivity. I want to feel productive. We have different ways to think about productivity, right? We have the productivity at the beginning of the project where you want to prototype and start everything fast and come up with abstractions and patterns and be able to give you speed. This is one kind of productivity. There is also the long-term productivity, is that as your software grows, you don't want to be burdened with maintenance. So you need to think about how the system is going to grow, and you're going to continue productive in the long term. The second one, how we're going to continue productive in the long term, is already very well tackled by OTP, which is a library that ships with Erlang, and it has all these ideas on how you're going to build systems and make those systems robust long time. So I'm going to talk about the first one, about the prototyping, and be able to write constructs that make me feel productive. So in order to achieve that, we have one thing which is called everything's an expression. This is true for Ruby. This is true for CoffeeScript. I'm not sure if it's true for Python. Is someone from Python that can tell me if you have like statements and expressions, or is everything an expression? No Pythonists? Okay. They're all in the other room. Okay. So everything's an expression. So here's an example of Erlang code. In Erlang code, here, I'm defining a module called myModule, and I'm defining two functions. One is some function, and the other is called other function. Both of them receive one argument. And just for example, if I wanted to do this, if I want to print something while my module is being compiled, while my module is being defined, I cannot do this. This is not going to compile. Because a module in Erlang is a special place, and you can just put some very specific instructions in there. So we can't do this. However, in Elixir, we can. So here's probably our first Elixir code. So here's how Elixir looks like. So you can say, I'm defining a module called myModule, and here's the function, here's another function. And if you want to print something in the middle, you can just do it, and it works fine because everything's an expression, so you don't have this special module place. So here's for sure a very silly example, but keep it in mind because you're going to use it soon. So we can put everything's an expression, so when you compile the module, you can do random stuff. We are going to go back to this point later. The second point we have in Elixir for productivity are macros. And those macros, they are similar to how macros work in Lisp, and we're going to see some examples. But before I get to this point, let's talk very quickly about Elixir syntax. So we have column foo, which is we call them atoms, but languages like Lisp and Ruby are going to call them symbols. We have tuples, which is surrounded by curly brackets. So here's a tuple with 3 elements, and all the elements there are located contiguously in memory. And we have lists, which is surrounded by square brackets, which are linked lists. And the thing is, in Elixir, all Elixir code can be represented with Elixir structures. So we can do this. Imagine that we have a call to isAtom. So here calling a function called isAtom, passing the atom foo as argument. This is going to return true because foo is an atom. And internally, this is represented as a tuple with 3 elements. The first element is the function name, isAtom. The second one is the line. And the third are the arguments that I am passing to this function. So I can represent all code, all Elixir code, using Elixir data structures. And everything's like that. So 1 plus 2 is actually a call to the function plus happening at line 1, and the arguments are 1 and 2. So basically what this means, since I can represent Elixir code using Elixir data structures, it means that Elixir code can manipulate Elixir code because they are simply data structures of the language. So what happens is that here I'm defining a macro called unless. This is a very canonical example for macros. And in most languages, unless is a keyword. It's something special because you need to just evaluate the argument depending on the value of the expression. And in Elixir, it's not a keyword, it's just a macro. Because when you say at the bottom, unless true do exit, the macro is not going to receive the evaluation of this expression. It's not actually going to call exit. The macro is going to receive the representation. So it's going to receive the representation of do exit, and then we can manipulate it. And what we are doing here, the macro example, is that we are simply converting the unless into a negated if, which is actually what unless is. Right? So here's an example of macros. And then if we put the fact that everything is an expression and macros together, we have domain-specific languages. One way for us to create domain-specific language. So here's an example of how you would write tasks in Elixir. So you can see that we're defining a module test. XUnit is the name of the test framework. And we have here a macro called test that's going to generate the test for us. And the fact that everything is an expression allows us to put the test macro in there. Because if we were like in Erlang, where the module is a special place, we wouldn't be able to put a macro in there. But here we can. So we have this test that's defining basic operations, and then we have the insertion. And what this test macro what the test macro does is actually really, really simple, is that it simply converts this, so the test with the string, into an actual function, so we can test it. So it's a very simple macro, but it's convenient because we can write our tests in a somewhat more readable way. And even more interesting, depending on the language you use, this is true for Ruby, Python, Java, you have like test unit frameworks. And what you need to do is that you need to use things like assert equal, assert member, right, when you're doing your assertions. And why do you need to do that? Because you need to tell the test framework, like, hey, I'm actually comparing those two, so in case this thing fails, please give me a nice error message. In Elixir, you don't need to do that, because assert is a macro, and as it is a macro, it can see what is the expression. So it says, hey, I'm actually comparing two things. So I know that you are doing something like assert equal. You don't need to tell me. You just write assert, usual code, usual Elixir code. You don't need to worry about assert equal or assert member. And then you're going to figure things out and give you the proper result. Okay. So this is the first goal, is productivity, is to be able to create domain-specific languages that's going to make you more productive and tie the language to your domain that you are working in. The second goal is extensibility. And this one is a critique more direct to Erlang. So this is some Erlang code. And here I'm defining a module JSON. And this module JSON has a function to JSON that needs to convert an item to its JSON representation. So you can see here that we have many clauses, like when this item is a list, here's how we convert list to JSON. When this item is a binary, here's how we convert binaries to JSON. And that's how you go, right? So in Erlang, you would define this code, you would compile it, put it on GitHub, and call it a day. But what happens is that you want to use this code in your application, but your application has a special data structure like an array. But this code does not know anything about arrays. So what are you going to do? You cannot extend this code in Erlang. You would have to fork the library and teach it how to convert to array, but you can actually not contribute your changes back because the array just makes sense in your application, so you have to maintain this fork of the project. Elixir solves it using protocols, and this is similar to what languages like Clojure are addressing this issue. So protocol is basically a way for us to do polymorphism, which are used as Ruby developers and Python developers. So what you're going to do is that you're going to say, I'm defining a protocol, JSON, and for you to implement this protocol, all you need to do is to implement the function toJSON that receives an item. And here in the bottom, we can see how we call this protocol. And what you're going to do is that the library can implement the protocol for all the types in the standard library. So, hey, here's how you implement the JSON protocol for lists, and then you type the implementation. Here's how you implement the JSON protocol for binaries, and that's how we roll. And then, eventually, when you need to use this code, and you have your own array data structure, and you want to use the protocol, you just implement the protocol for our own data structure, and then you call it a day, and then you ship your code. Right? So you are extending the library, and you're doing polymorphism. So even if the author of the library did not know about array, you can just extend and teach the library how to manipulate your code. And then we use this for enumerators, so how you can iterate structures. We use this for us to tell how we should print structures to the screen, and it's really useful when we are writing Elixir code. So this is the second goal. And the third one is compatibility. I was saying at the beginning of this talk that one of the main goals of Elixir is exactly to be able to write, to be able to use their Erlang virtual machine. And I know I'm going to throw a bunch of buzzwords on you now, but it's true. So I want Elixir developers to be able to build distributed, fault-tolerant applications with hot code swapping, because this is what Erlang developers, they are building today, and an Elixir developer should be able to do the same. Okay? And the way we do that is that there is no conversion cost for calling Erlang for Elixir and vice versa. So there is no bridge, and this allows us to integrate fairly easily with all the Erlang libraries and tooling out there. Okay? There are many other improvements on the language. So if you compare with Erlang and in general, so we have UTF-8 binary strings. Erlang is still using ISO Latin something. So we pushed everything to be UTF-8 binary strings. We have keyword arguments, which are coming to Ruby 2. We already have them in Python. We have first-class documentation. This one is similar to Python's and Clojure, where you can actually attach the documentation to a function. And it's a special string, and it's easy because if you want to query the documentation, it's very easy to do. We have first-class regular expressions. Ruby does that. I think Python does not. So in Python, if you want to use a regular expression, you need to first compile it, but you compile passing a string, and then you need to escape the escape characters, and it gets messy really quick. So we have a first-class regular expression. We have zero-index access. This is not supposed to be a feature, but in Erlang, we have lists and tuples, and the way that you access the first element is using 1. But in binaries, you access the first element using 0, so it changes in Erlang libraries. And then we said, okay, let's stop with this, let's normalize. Everything is 0 index-based access, and 0 is going to access the first element, and many other improvements. Okay? So in order to finish the talk, I want to give a very quick example on how we designed the test framework, or how the test framework is being designed. So here is the example that we saw earlier about a test case. And here we can see that there is one difference, that we are passing the keywords argument async true when you say use XUnit case. And the reason we do that is because if your test case is not talking to a database or talking to the file system, it's not going to generate any side effects. So what you can do is that you can run all those test cases in parallel, right? And this is how we do by default in Elixir. There's a lot of things in Elixir that we do in parallel. So when you compile code, when you load code, you're doing all that in parallel. So if you install Elixir and you do something like make compile test, you'll see that your CPU, all CPUs on your machine, they're going to get crazy because you're trying to do as much as we can in parallel. And the way it runs internally is that we have here on the right, you can see two main structures, which is the XUnit runner, which is the one responsible to coordinate everything, and the XUnit formatter, which is responsible to print the test results to your screen, for example. The formatter can be anything. By default, we have a CLI formatter that just prints the test results to the command line. It could be something that prints to a file, or you can have eventually a WebSockets formatter that prints on your browser, whatever you want. And here on the left, you can see all the test cases that you defined. And the way we do that in Elixir is that all of those, they are actors. And the way they work is that they are just exchanging messages with each other. And those actors, they're all running concurrently all the time and exchanging messages. So the XUnit runner, if you have 4 cores, it's going to say, no, I'm going to start like 4 test cases in a row. So it's going to send a message to the first, then to the second, to the third, and the fourth, and then all those tests, they are running at the same time. And then as soon as one of those finish, it's going to say, hey, I just finished it, and then it's going to send a message back to the XUnit runner and say, hey, I was the math test. By the way, I had 5 tests. 4 of those tests passed, 1 of those failed, and here's the reason why this test failed. And then XUnit runner is going to send a message to formatter. This is what happened, so print to whatever you should print. And then the runner is going to say, now it's time for the next test to run. And that's how it works in general. So just to give an idea of how we are just sending messages across those actors. What is very interesting here is that we have a feature called location transparency. And what location transparency means is that since everything is modeled with message passing, the way it was designed is that it actually does not matter if those actors, they are in the same machine. They could actually be in different machines in the same network. And that's just going to work just fine because it knows how to send messages across different nodes. So what you could have is that you can have like a machine in the corner of your office that's just running the test for you. Every time you say like, hey, run the test, it's going to run all the tests for you. And then you have the formatter in your machine because that's where you want to see the messages. And it's just going to run just fine, and the messages are going to go through the network. And after all, we can also add a supervisor on top of it. So Erlang has a philosophy, which is basically you should not be fighting the crashes in your code because your code is eventually going to crash. So what is the most important thing for you to do since the beginning is what is going to be the strategy, how you're going to react when your code fails, because it's going to fail eventually. Something is going to go wrong, maybe a connection to the database, somewhere it's going to fail. So what are you going to do when it happens? So we have the supervisors where you can define the strategies of how you should restart an actor when something goes bad. So that's the whole idea. So that was a very quick, short talk. Here is our website. If you want to learn more about Elixir, if you're interested, we have a getting started guide, so you can just go there and get more information. I want to thank my company, Platform Attack, that allows me to spend a good time of my time working on the language. And that's it. So we are Elixir, and here I was on Twitter. Here's the website, elixir-lang.org. You're not supposed to have a text there, so just ignore it. And we are also on IRC. So if you come to elixir-lang and you want to talk, that would be great as well. So that's it. Thank you. So what I want to do, in light of my questions, I want to show some code running. And I already saw that we have a question. Please tell me.
Okay, so you see, it seems that you have a lot of features that are in Clojure. Do you plan to also have multi-methods?
So the question is, we already have features that are similar to closures. And this, just a little bit of background. The first people that came to play with Elixir, they were Clojure developers. So we have a build tool called Mix that's inspired by Clojure's Linehan. And we don't have multi-methods yet because I still haven't had a need for it specifically. But since it's macros, you can probably write it yourself. There's no need to have a support of the language. And then as we see fit, we can extend the language with those features. So, yes, tell me.
It's not the question. I just wanted to say that Python does have statements.
Yes, so Python does have statements. So everything is not expression.
They're hackable in predictable ways.
Okay. Thank you.
Do you have some special language constructs for actors and message passing, or is that fairly standard Erlang?
The constructs, they are similar to Erlang. So the question is if we have constructs for message passing. The constructs are very similar to Erlang. I'll show them now, just for you to have an idea. Okay, so can everyone see it? Should it be bigger? Is it good? Good? Okay. So here we have interactive Elixir. And here I'm starting one interactive interactive Elixir shell, and I'm giving it a short name foo. A short name is going to make this node running the code available on my machine, right? So I will start interactive Elixir here, and then you can do all the usual things. 5 minutes, thank you. 1 plus 2 is 3, and all the basic stuff, right? And on the other side, I'm going to also start another interactive Elixir and give it a name bar, okay? And what I'm going to do is that I'm going to define a module called hello. I know it's a little bit cliche, but hold on. So hello world, and all this is going to do is print hello world. And then it's defining the module. And then I can type hello.world and it's printing hello world. So far, so good, right? So what I'm going to do now is that I'm going to go back to the other node, and I'm going to type hello.world here. And it's not going to work because I defined hello world just in the other one. But what I can do is that when I started the node, giving it a short name, it gets a name in our local network, and this name is bar, which is the name of the node, at JVMP, which is my machine. So what I can do is that I can just say, I want to execute instructions in the other node. So I can give it the name of the node, which is bar at JVMP, and say, I want you to execute the instruction. I'm passing a function now, which is hello world. And then when I do this, come on. Yes! So the first one is to warm up. So you can see that it printed hello world, and it worked because it went to the other node, it executed the function in the other node, and then it came back. And what is interesting is that the hello world was printed in this machine, in this node, and not in the other one, which is actually what you want in real life, right? If you have a production system and you want to connect to it because something is odd, and then you are printing stuff and you're getting information, you want everything to come back to your machine. You don't want that printed there, right? That's not going to be useful. So here's, just to give you an idea how easy it is to execute code. One of the things it also talked about was documentation. So we have first-class documentation, and it's very easy to retrieve this documentation. So if you type help enum, it's going to show you the documentation for the enumerable module, and say, okay, what are the functions that are available in enum? You can get a list, and then you can ask documentation for the all function, and it has examples. So the documentation is very easy to explore, and that's very important for us since we are a new language and you need to come up with it fairly quickly. You need to learn it very quickly. This helps a lot. One of the questions was about message passing. So in Elixir, all your code, it runs inside actors. And those actors, they have a mailbox. So you send messages, and then you eventually need to process what is in your mailbox. So what I'm going to do here is that self, it identifies the current actor, right? We call it a process, but it's the Erlang virtual machine process. So what I can do is that I can send a message to myself saying, I'm sending the message hello. And what I can do now is that, so I have this message hello in my mailbox, and then every time I want to check what is in my mailbox, I can use receive and say, okay, I want to check the messages that I have available, and in case I have the message hello available, I want to print got it. Right? And then I do this, it prints got it, because I had the message hello in my mailbox. If actually, when I executed this code, I didn't have any message hello in my mailbox, it's going to wait until a message arrives because another process is going to send me this message. Okay, we have a couple more time for questions? 4 minutes, woo, okay. So, questions?
Can messages be arbitrary data?
Yes, the message can be arbitrary data.
Functions, for example. Can I send a function to another?
Yes, you can send a function to another function. Yes, and usually what you do, so the question is if the message can be arbitrary data. And yeah, so usually what we do is that Elixir has pattern matching. So the way we do pattern matching is that, for example, you can define a tuple, and this tuple, you can say, oh, it contains a function. We usually like to tag the tuple so we know what are the contents inside. And then let's suppose this function is a callback, right? That's adding 2 elements. And then what I'm going to do is that let's send this tuple to my mailbox. So I can send the tuple. And what I can do is that you can say, when I'm receiving the message, I want to receive the message where it's a tuple, and the first element is a function. And then here, I'm going to match on the function. and I will execute the function code testing 1 plus 2. I don't need to print it, okay? So now you can see it returned 3 because I sent a message to myself. It was a tuple. The first element was an atom saying, hey, what we have here is a function. It's just for the code to be readable. And then we are passing the function, and then we receive this function and executed it. Right? So we are like pattern matching. Is a way to say, just to do an assertion of the content what is in there. Right? So if I go back to this tuple, right, it's a function and another function. If I try to do something like compare it with let's call binary and compare with the tuple, this is going to fail because, I'm giving it on the right side, I'm giving a function, but I'm expecting a binary. So it says you cannot match, and here's how we match on Elixir data structures, and this is pattern matching in general. Before, I want to show something else very quickly. I was talking about a tool. We have a tool called Mix. When you install Elixir, if you go to the website, it tells you how to install Linux, Windows, Mac, and you can type like mix new foo as soon as you install Elixir, and this is a tool that's going to create a new project for you. So you can just go into the project, and then you can run tests, and then you can start writing your code very fast. So this is something I like to show because it allows you to get started very easily. We have a little bit more time for questions. Do you have more questions?
What kind of applications are there already written in Elixir?
So that ships with Elixir?
Yeah.
What are the applications that ship with Elixir? So we have 5 main applications. One is Elixir itself. The second one is interactive Elixir that I just showed you. The third one is embedded Elixir, which is a way for you to build templates which has Elixir code in the middle. So if you use Ruby and we have ERB, we have EEX, which is embedded Elixir. And then we have XUnit, which is the test framework. And then we have Mix, which is the one I just showed. So we have like 5 built-in applications.
So recursion works as you told me.
Yeah, so in Elixir, we don't have loops. We don't have like while loops you do recursion because we have tail call recursion. And it's very interesting because it's a different way to think. And you use recursion with pattern matching, and it gives you like very powerful constructs to do iteration and so on.
It optimizes tail calls.
Yes, and the language optimized tail call, it comes from the Erlang virtual machine, and that's the only way to do it. Over. Okay, so if you have questions, please come talk to me after. I'll be glad to answer them, and thank you very much.